Hey, John here. Let's take a closer look at how to draw lines using Postscript. You might remember some of this bit of code from the earlier video in the introduction. Let's interpret it using Ghostscript and see what's going on here. Give ourselves some room here to look at it. All right, so what do we got? First thing you need to do is you need to create a path over which you're going to stroke a line with like a virtual pen or pencil. So you say, I want a new path. Then you need to go somewhere on the page. And remember, these are in typesetter points, the units are. So there's 72 points per inch, so this will go over 1 inch from the lower left corner and up 1 inch like this. Then we want to say, from there, I want to draw a line from the current point to this other point, which is going to just be 2 inches up from the bottom of the page. So it'll be put a marker down here and then draw a line up 1 inch. All right. Then we want to stroke the line, and you can now see it on the Ghostscript rendering. You don't see it on paper. If this was going to a printer, it wouldn't render the page until you say show page. And in Ghostscript, what happens is it says press return to continue, because at the end of a page, you'll see it clears the screen over here. And that makes sense because you don't want all the stuff from page 1 replicated onto page 2. So let's look a little more at what's going on here. Let's create another line. Again, we got a new path and go to some starting position. Then we're going to say go up. This is the same line up. It looks like it's going to go from the starting point at 1 inch in the x-axis and go up another inch, just like it did the last time. Then it looks like we're going to go from there. We're going to go over 1 inch in the x dimension. All right. Then we stroke the line, and of course you don't see it until you say stroke the line, and we go. This is 1 inch over 1 inch up. We draw a line up 1 inch, a line over 1 inch, all right? And on a printer, you'd say show page. So what else is going on here? We know about moveto and we know about lineto. Now we've got setlinewidth. So let's create a new path. This time, let's say, make this line width 20 units wide, 20 points wide. And this is the same code that we were just looking at. So it's going to go here and draw 2 line segments. And now we can see this is a much fatter line than it was by default. I actually don't know what the default line width is. Maybe it's 1 point. I don't know. And of course, show page to end that page and clear it out and start a new one. So let's look at a triangle. And I say this is going to be messy because what's going to happen is when you go all the way around and come to the end, you'll see there's an inconsistent ending point there. So again, we need to draw a fat line to exemplify what's going on here. This goes over 1 inch, up 1 inch. This is the same first few lines that we saw before. Now what we're going to do is we're going to draw a line back to the beginning part. So it goes up, over, and now we're going to come back down around here, right? And stroke those lines, or more accurately, you would stroke the path that has been described, all right, the path of movement. All right, so what's wrong with this is that you don't have this, it won't close this off. You see these nice clean mitered corners, and this one has got a big gap there. All right, so let's end this page and look at how we can take care of that. So one thing we can do is we can say close the path. This is the exact same code that we just looked at. But before we say stroke, we say close the path. So it knows it's got to be circular, you know, a continuous path. Now you can see that the path has been closed, that it miters all 3 corners the way you would like it to look. Now, because we've closed the path, we don't even need that last point. So if you look at this, what we've got here is the start 1 inch over 1 inch up, draw the vertical line, draw the horizontal line. We don't have to draw the whole hypotenuse of that triangle to close the path. It'll still close it even though there's a gap in there, all right? And then you end up with the same thing, all right? So there's one less thing you really have to do. All right, so notice that we changed lineto to rlineto. These are, I like to think of it as a relative line. So this is going to be the same shape drawn a different way. Let's look more closely at what's going on here. We've got a new path. All right, we're going to make the line width 20 again. just like we did before. We have to go to a place on the page to start our path with. But once we have a position, an absolute position, we can move around relative to that position. So what this one is, relative to where I'm currently at, which is this 1 inch over 1 inch up, I'm going to go 0 in the X and 1 inch up in the Y. All right. Now I'm going to go 1 inch to the right of X and 0 in the Y. Okay. And close the path, stroke the image, and we again have the exact same triangle we did before. The neat thing about this is that I can change where the triangle is by changing these numbers here and leave the rest of the code alone, which is sometimes a real annoyance. You know, if you write a little program, you want to move it around on the page, all I need to do is change the move to, and everything else is drawn relative to there. So let's go ahead and clear the page and do this whole thing again. All I've done is change the move to, and voila, the triangle is now somewhere else. Sometimes I rearrange my code a little bit to make it more convenient to relocate things that are drawn with relative paths like this. And I might put the initial position up here, because remember we're dealing with a stack. If I put 200 and 200 in there, and we look, it's in the stack. Newpath doesn't use any of the path. As you can see, there's still 2 elements in there. And it's the initial values up here. And if I say move to, well, remember what move to does. You're going to think very literally now. It's going to pop an X and a Y position off the stack and go there. So the move to executed here consumes the values from the stack that were up there earlier. And there's nothing wrong with that. Now, we draw the rest. All the rest of this is the exact same code we had before. And now the triangle's up here because 200, 200 is different than where we started last time. And having it up here in your code like this, you could leave an extra space down here or write some more better doc about what this is used for future reference. It makes it easier to move this triangle around. All right, so I have a couple of notes here to myself, to remind myself, to tell you guys, look, if you have a path, you start yourself a new path, you need to have an absolute position to start it with. I can't just say rline2 something, right? 5, 15, or whatever it's going to be. It'll come back and it'll say there's no something about no current point right here, okay? I cannot go relative to something that has not yet been defined, all right? So that's broken. All right, so this is also going to be broken, right? If I put the 200, 200 move to on here, and then I say new path, well, what I've done is I've deleted the context of a path, which means this point up here is gone now. So if I now do an rline2, it'll give me the same error. There's no current point, all right? So you cannot say new path and then start drawing relative. All right, so this begs a couple of questions. How come I can do this and then say rline2, oops. And it works, right? I didn't create a new path. Well, the answer is there's always a path. The new path command or operator simply says, regardless of what you have in your context right now, start it from scratch. Clear out the path. I'm starting a new one. And there are plenty of times when the position will be left somewhere on the page, and you want to get rid of that. So let's see what happens if we do this, right? Do that, and we do a stroke. So the question now is, what is the position now? Do I need to create a new path? Will this thing work? Well, if I do an rline2, that should reveal some inner thinking, and the answer is no. At the end of a stroke, there is no current point. The path has been consumed by the stroke operator. So technically, you don't really have to say new path all the time, because the stroke operator will have reset the path to the same state as the new path operator would do. Let's clear this page off. All right, now what do we got going on here? Contiguous line segments. All right, if we do this, you'll notice there's a move to in the middle of this path. So the path starts at our 1 inch over 1 inch up. We're going to go up 1 inch because this is 72 up in Y, and remember Y positive goes this way. Then we are going to go on a 45-degree angle up this way with a line, and now we have our move to, which is go up into the right another 45-degree over 1 inch and up 1 inch, and then we've got another line, and then we go, looks like downward 1 inch there, and then we draw that. So let's put this on the sheet and see what happens here. Let's clear the stack and run this. All right, so the one stroke command actually drew two separate things. It's okay for a path to have lines as well as moves in the path. That's the takeaway here. Here's the same exact program again, but I've added a close path at the end, all right? So the interesting thing here is, what does it mean to close a path that has a gap in it? Because the path technically wouldn't be closed. Well, what happens is this happens. It'll close the last thing that can be closed. It doesn't go down here to the beginning of the path. That's not what close path does. It goes and connects it to the last contiguous line. So let's look now at what it means to fill something or set different colors or gray levels and things. So let's make a fat line like we did before. We're going to create a path. This is going to go, where is it going to go? 400 in X and 20 in Y, so it'll be over here somewhere. And then relative to there, we're going to draw a line up, and then we're going to go to the right. It'll draw another triangle, close the path, and then it's going to say gray. And instead of stroke, we're going to say fill. All right. This one is going to create a rectangle that is a solid color rather than an outline. Okay, and there it is. That's what fill does. And of course, set gray. This is 30% gray. 0 is black, 1 is white, and 0.3 is 30% gray. All right, now with that still on the page, what happens if I draw on top of it, right? So now I go 450. That'll be way over here. Then I'm going to draw, I don't know if that's going to draw on the same spot or not. Oh, yes, it does. So now you see I just drew a black triangle on top of the gray one, and this one I stroked instead of filled. So what is the takeaway here? Well, the last thing drawn covers up anything drawn prior. What else is interesting about this is I never told it what the line width was. Well, the line width was left over from code that we executed earlier. If you scroll way back here, a couple of examples ago, the line width was set to 20 way 2 or 3 triangles ago, all right? On my screen, it's way up here somewhere. All right, so the line width and the gray persists after this stroke or fill has been completed. All right, so that part of the graphics context is not consumed by the fill or the stroke. They persist. All right, so let's say we want to draw a triangle with a gray inside, an outline triangle, but we want to make it gray inside. So, or we can use color. So I'm introducing a few things in this example. Let's go and create a triangle. Starting point, we go up in Y, over to the right in X. We draw that triangle. We then set a line width, and we make it a color instead of a gray. This is red, green, and blue expressed as a percent. So that's 100% red, 50% green, and just a little bit of blue. I guess that's kind of an orangish color. Now, look in here, we got gsave and grestore. These commands save what we call the graphics context. Well, one of the things that the graphics context includes is the current path. So if I save the graphics context and then I say stroke and then I restore it, and the graphics context works just like the operand stack does. There's a completely different stack for graphics contexts. You can keep saving them and restoring them. So what I'm going to do is I'm going to do a stroke. It will consume the path. Then I'm going to say restore the graphics context, which gets me the old path back. And in doing so, if I change other things in here like the line width or the color and stuff like that, that too would have been restored to what it was up here, all right? And then I'm going to change the color to something more blue-greeny, instead of the orangish color, and then I'm going to fill the triangle with that. So let's see what this looks like, right? So here's my my first triangle. I don't know where that went. Oh, it's way up there. Okay. Move this over like that. And then from here, I'm going to restore the graphics context. I'm going to set a different color, and then I'm going to fill this. Now watch what happens around this edge here when I run the fill. You'll notice half the line was lost. Well, we know that from the previous example that things drawn later can cover up anything underneath it that was drawn previously. And since a line is drawn about its center in the path, right? This triangle here, when I said move to its starting location, the starting location was really right there. And then I said draw up, and it stopped right here, and so on. So these lines are centered around the path, okay? Therefore, when I fill this one, the fill fills the interior of the path. So it makes sense that this one will have covered half of the width of the line that went around that triangle. So order matters is the takeaway there. If we reverse the fill and the stroke, obviously it would do something closer to what we might have wanted, right? If we say, give me two triangles. Again, all I've done here is I've reversed the fill and the stroke order. And we do this instead. We now have the fill being done first and the outline being done second. Let me do a show page here, clean all this out, and run this again, just so you know I'm not faking it with old data. Okay, there you go. Right? So the fill went first, and the line actually does cover part of the fill, but this might be closer to what you were aiming at. All right, so now what are we going to do? We have options on what we're going to do when we come around the corners of our triangle. So these are mitered corners, they say. Let's look at what happens if we change this line join setting. I think I'm going to draw this one over to the left there a little more. So let me move that. Let me do a show page. Clear off the page. All right. Reset all the graphic stuff. And let's draw, what is this, another triangle, 50 and 400. So that's a little bit over and a lot up. And then I'm going to go up and to the right, close that off. And you'll notice the set line width down here applies to the stroke. It does not apply to the lines, okay? It's the stroke operator is what looks at the line width. So I could set it way up here, I could set it here, I could set it anywhere before I say stroke. This is the setting used by stroke, as well as the colors and everything else. You can't say like set green and then do a line 2 and then set blue and do a line 2. No, that's not how that works, okay? If you wanted to do that, you'd have to say move somewhere, do a line and set green and stroke that line, and then create a new path and set blue and then draw a line and stroke the next path in blue if you wanted to change the colors as you went. All right, so the line width, the gray, the color, the line joins, and all this other stuff, these things apply to the stroke, not to the drawing, not to the path that's being created by these line 2 operators. Okay, so let's run this and see what happens. Okay, so there's our triangle. We close the path like we know. We make the line width 20, and this proves that it applies to the stroke and not to the line segments in there. We want it black. Now we've called this setlinejoin thing, and we've given it a parameter. If you set it to 0, that's the default that you're used to seeing with the pointy corners. A 1 means round them. Well, obviously these are rounded off. If we set it to 2, it'll use beveled or chamfered corners like this. So let me try that one. And we'll call show page to clean this up. And we'll run the whole thing again. And now we've got these beveled off corners like this. All right. All right, let me do a show page here, clean off the sheet. So what do we got going on here? We just talked about line join, right? Now we're going to talk about line cap. This applies to the ends of lines. So if I just drew a single line segment right there, it has two ends. Well, what should the ends look like? Do you want them to be round? Do you want a butt joint and so on? Well, the lines we've been drawing so far use butt joints, and I'll run each of these and we'll show you a little bit about what these things look like in a second. So let's look at this. We've got two lines we're going to draw. Let me make this window a little bit bigger. Okay, so see this one set gray right there? So what we're going to do is we're going to make one path and stroke the path using different line caps and having 20 points of width. Then after that, we're going to stroke another line. Like I said earlier, if you want to draw two lines in different colors, you have to create two paths and stroke them independently. So this one up here, the current gray level is 0. I probably should put that in here explicitly. 0 set gray. Okay. Now I need another line down here. There we go. Okay, so this one's going to be black, and it's going to have we can play around and draw different line endings on them. This down here, what's he going to do? It's the same beginning point, same R line 2, so that's just 100 points straight up in Y. Then what do we got here? This one down here is going to always use butt caps. It'll be 2 points wide, rather than this one's going to be 20, and it's going to be white instead of black. All right, so now I'm going to draw a white line on top of a black line. So let's just draw 2 butt lines first, and we'll see what this looks like. All right, and then we'll try the other one. So let's do that. Just draw 2 lines. Well, that makes sense. They're both butt joint lines. In a butt joint line, what happens is the starting point is exactly at the end of the line, and the ending point is at the other end of the line, okay? And it would make sense that if I drew a white one on top of a black one that was skinnier, it would look exactly like that, all right? Now, instead of a butt joint, let's draw a rounded line, but leave the other code down here that draws the white reference line the same. Do a show page to clear off the page. And now we're going to see what a butt joint really is. Well, obviously in a butt joint, what happens is the line extends beyond its terminal points. All right? So it creates this rounded circle that extends beyond the end. Now a projecting end is like a butt joint, but instead of rounding it, I should have said, it's like a rounded end cap, but instead of being round, it will be squared off. Let me do a show page here. And you can see it extends off the end just like the rounded end, but it's squared off, okay? So a butt end is right at the point, projected end point is extended much like the rounded one is, but with square corners, okay? So this should get you started drawing things that are comprised of lines, including shapes that have filled interiors. Thanks for watching. Let me know what you think in the comments below. Happy coding!